Good morning to all. Here we are going to discuss one more frequently asked question on inverse Laplace transforms. Now let us discuss that. Now just look at find L inverse of s square by s square plus a square into s square plus b square, where a, b are constants not equal to 0. Constants not equal to 0. This is the question. Actually, this sentence was not given in the OE examination paper. It should be given where a, b are constants not equal to 0, and also a is not equal to b. Should be given. Okay, leave it. Now here we have to find the inverse Laplace transformation of this signal in frequency domain. So how do you call f of s? F of s is a signal in the frequency domain. We are calling it as f of t. F of t is a signal in time domain. Understanding what is f of s? F of s is a signal in the frequency domain. Yes, that word should be different. Now for this you have to find the inverse Laplace transformation. Now just look at how do you write s square by s square plus a square into s square plus b square. Now just look at, it seems to be a different from that of all the previous problems what we did. Here it has two factors, so we need two fractions. Each fraction, the degree of s in a numerator 2, the degree of s in the denominator 4. So degree of denominator is greater than that of the degree of s in the numerator. Now how many factors are there? 2 factors. Each factor of degree is of 2, not 1. So whenever it is 2, make it as as plus b by s square plus a square plus, for example, some cs plus d by s square plus b square. Let the equation be 1. Equation be 1. Now just look at, this is the important step students have to observe. This is quadratic nature. Both factors are of quadratic nature. So in the numerator you have to go for linear way. Now next to find LCM of the entire one, that equal to, you have to find as plus b into s square plus b square plus cs plus d into s square plus a square. Now just you have to make it like that. After that, how many constants are here? 4 constants are here, a, b, c, d. For 4 constants we have to make 4 numerical equations to solve them. So how do you solve it? Here first you can make it coefficient of s square, compare it, one equation. After that, compare coefficient of s cube, second equation. Next, compare coefficient of s both sides, third equation. Fourth one, compare constants both sides, fourth equation. So now here you have to write compare coefficients of s cube, s square, s and constant both sides. Now you have to solve it. The solving process is left to you. You have to solve because you already solved these partial fractions, intermediate paper 1A unit 2. Understanding? To find 4 equations. Upon this one, you get, after that, after solving, we get a equal to 0, that equal to c. Got it? B equal to b square by a square minus b square, and b square by a square minus b square, and d equal to minus a square by a square minus b square. Now let it be equation 2. Understanding? Equation 2. Look at all these values we got after solving 4 equations. How to solve these 4 equations is left to you. You have to make it. Directly I am writing the values of A, B, C, D here because of the time constraint. Understanding? So now put the equation 2 in the value of 1. Now here which one is 0? A is 0, C is 0. Now this implies s square by s square plus a square and s square plus b square. That value is equal to, what is the value of b? B square by a square, that is equal to b square by a square minus b square into 1 by s square plus a square. Next, what is the value of d? Minus a square by a square minus b square into 1 by s square plus b square. Now taking L inverse both sides, this implies L inverse of no need to write the entire fraction always. L inverse of f of s is equal to b square by a square minus b square into L inverse of 1 by s square plus a square minus a square by a square minus b square into L inverse of 1 by s square minus b square. Now just look at, just applying inverse Laplace transformation both sides. This is equal to constant b square by a square minus b square. For L inverse of, in the previous case we already explained, L inverse of sin at is equal to a by s square plus a square. Therefore L inverse of 1 by s square plus a square, that equal to 1 by a sin at. Apply this one. This is equal to 1 by a into sin at minus a square by s square plus b square. A square by a square minus b square, same 1 by b into sin bt. Now got it? Now what output we got? The value of a, b is, the value of b is not b square, this is a square. The value of b is equal to a square by a square minus b square. This is not a square, this is b square. So now this is a square, constant a square by a square minus b square. This is b square. Now this also the value that is equal to a square. This is b square. Now this is a square by a square minus b square. This is also b. Now here a cancel by one time, that is a by a square minus b square into sin at minus b by a square minus b square into sin bt. Now taking 1 by a square minus b square both sides common, we will get a sin at minus b sin bt. Now just look at, this is equal to f of t. Understanding? This is equal to f of t. So this is the way of solving this inverse Laplace transformation problem. It is one of the frequently asked questions in OU examinations. So here, take this one, s square by 2 factors. So 2 fractions, taking the LCM, comparing the coefficients of both sides, you will get the values of A, B, C, D. Substituting these values in the given equation 1, you will get like that. After that, taking inverse Laplace transformation both sides, you will get this is the one. So these are the problems on inverse Laplace transformation. Students have to observe very carefully. One important point is that these partial fractions, you are supposed to make it because of the time constraint. Here, time is not allowed for me to solve all these questions, all these linear equations like that. So this portion, this small portion only left to you. You have to make it because you are already aware of how to solve that partial fractions to get the values of A, B, and C and D like that. Thank you.